Okay, in this video, we're going to look at key features of polynomials. And a lot of this is stuff that you've already seen before. We did it with quadratics, but now we're going to be doing it with polynomials. So x-intercepts, we all know what an x-intercept is. An x-intercept is where my graph crosses my x-axis. And so if it crosses my x-axis, you can see that there's one here. This is an x-intercept. So that value, that coordinate is negative 1.732 comma 0. I gave you that one because it wasn't a nice graph, or it wasn't a nice point. So notice that the y value for my x-intercept is 0. This is also an x-intercept, and that is our origin, which is 0, 0. Again, the y coordinate is 0. And this is an x-intercept, which is 1.732 comma 0. So an x-intercept is where my graph crosses the x-axis. I will always have 0 for the y value. Okay, we also know what a y-intercept is. A y-intercept is where my graph crosses the y-axis. And so this point here happens to also be a y-intercept. And so our only y-intercept is our origin, which is 0, 0. Now, I know it's hard to tell because this point happens to have both coordinates be 0, but for a y-intercept, which crosses my y-axis, my x value will always be 0. So on other graphs that we look at, when we find the y-intercept, the x-coordinate is going to be 0. Okay, so let's talk about domain. We've talked about domain before as well. Remember that domain is what x values would I be allowed to plug into my function, or which x values can I see on my graph? How far left and how far right on the x-axis can I go? So here you see that I took a screenshot of this graph. So you can see that this goes all the way here and it stops, but it's because I took a screenshot. So this would continue on and we could put an arrow at the bottom. And this one also continue on and we could put an arrow there. And so as this continues down, it's going to get a little bit wider and a little bit wider and a little bit wider. So it's going to keep going in this direction. And as this one goes up, it's going to get a little bit wider and a little bit wider and a little bit wider. So it's going to keep going in that direction. And so for this case, our domain is all real numbers. And you guys should be familiar with that. Okay, our range then is what y values can our graph have? What y values do we see on our graph? And so if we look here, this is a pretty high y value, but this one keeps on going. So it's going to keep on going and keep on going, and I'm going to get higher and higher. And this one, as it goes, I'm going to get lower and lower, and that's never going to stop. And so for this example, my range is also all real numbers. Now, that's not the case for all of them, so you have to look at it carefully. But for this one, it is also all real numbers. Okay, so now we're going to look at a few things that might be new to you. So we're going to use the same graph. So remember, there's an arrow here and an arrow here because it keeps going. But we're going to look at, where is our graph positive? Where is it negative? And then where is it increasing and where is it decreasing? And it's very important that you understand this because these things are very easy for people to get mixed up. Just because my graph is positive does not mean it's increasing, and vice versa. Okay, so when we talk about where's our graph positive, we're going to think about where is the y values positive. And another way to look at that is when my graph is above the x-axis. So when I have positive y values, my graph will be above the x-axis. So we're going to start to the left here and we're going to start tracing it. So that's how we read a graph. We always start as far left as we can and we trace our graph working towards the right. So if I'm tracing it, I'm actually below the x-axis. So my y values are negative and I'm still below the x-axis until I get to this point, which has this x value. So at this point, I'm actually at 0. You can see the y value is 0. But right after this point, I'm above the x-axis. So my y values are positive. And I'm still above the x-axis and I'm still above it. So my y values are still positive until I get here. So between this location, this x value, and this x value, I'm above the x-axis. So we would say when x is between negative 1.732 and 0. Now, after this point, I'm below the x-axis, so I have negative y values, and I'm still below the x-axis, but at this point, which has the x value 1.732, right after that, I start being above the x-axis again, and then I will continue to be above the x-axis forever, for the rest of the graph. So from this point all the way to the right, I'm above the x-axis. My y values are positive. So we're going to say also when x is greater than 1.732, okay? So now what does negative mean? Negative means when y values are negative, which means my graph needs to be below the x-axis. So again, I'm going to start tracing. I'm going to ask myself, am I below the x-axis? I am. I'm below the x-axis. So my y values are negative. You can see that. I'm in the negative area of my graph as far as y goes. So I'm below the x-axis and below the x-axis until here, which again, be careful, it has this x value, not the -2, that's this point. So I'm going to be below the x-axis, let me erase these, below the x-axis to the left of that point. So when x is less than -1.732. Okay, well, right after that point, we know I'm above the x-axis. We just talked about that, and I'm above the x-axis. But then after this 0 here, I'm below the x-axis again, and I'm below the x-axis, so my y values are negative until I get to here. So between this point and this point, my graph is below the x-axis. So we would say when x is between 0 and +1.732. Okay, so that's how you have to do this. You have to trace it and ask yourself, are you below or are you above? And then you have to give your answer based on the x values. All right, so now let's look at this and let's look at what's the difference. What does increasing mean? If my graph is increasing, it's going up. And it can be going up even if it's not positive. Okay, so positive is not the same thing as increasing. Okay, so we're going to start tracing our graph again, but we're going to ask ourselves, at this point, am I increasing? I am. I'm increasing. I'm still increasing. I'm going up, I'm still increasing, and I'm increasing until I get here. And we want to find that x value. That x value is -1. So I was increasing from the beginning of my graph all the way to -1. So we can say the left side. To the left of -1, my graph is increasing. So when x is less than -1, it's increasing. Well, right past that, it's decreasing and decreasing and it's decreasing. But at this point, right after this point, it starts increasing again. And this point is +1. So here I'm increasing and increasing, and then I will continue to increase for the rest of my graph. So to the right of this value, or to the right of 1, my graph is increasing. So when x is greater than 1. These are the two intervals where my graph is increasing. So now, if we look at this and we ask ourselves, well, where is it decreasing? And decreasing means going down. Now, not that this arrow points down. That just tells me my graph is going to go on forever. But we're not going down this way because we start here and we trace it. So we would be going up. So that's increasing. So if we start tracing, that's what you have to do. You have to trace it. You have to say it's increasing, it's increasing, it's increasing until we get here, which we know is -1. After that, it's decreasing. So this I'm tracing, my pencil is going down. I'm decreasing and decreasing and decreasing until I get here, which is 1. So between -1 and 1, my graph is decreasing. So we put x between -1 and 1. And you have to make sure when you write it in this that you have the smallest x value and the largest x value, and that you have your inequality symbols written in that direction. Okay, and we've used this notation before. So just be careful with tracing it and know the difference between positive and increasing and negative and decreasing. Okay? All right, last couple things we want to look at. Relative extrema means relative extreme values. So we want to find a relative minimum. And we talked about minimum values with our polynomials. We talked about minimum values with our quadratics. And so now we're just doing it with polynomials. But it is a relative minimum because it's a minimum relative to the points around it. So it's a low value relative to the points around it. So here, this is a maximum, actually. That would be a relative maximum. You can see that it's a high point. It's a peak. But this part right here, this would be a relative minimum because this point is lower than the point immediately to the left and the point immediately to the right. So it's a relative minimum. The coordinates of my relative minimum, if I wanted to know the coordinates, this is my x value of 1, and you can see that that's 2. So the coordinate would be 1, -2. But technically, I have a relative minimum. When we ask for the minimum value, we're talking about the y value. So I have a relative minimum of -2, and it occurs at x equals 1. So if I asked you for the coordinates, you could give me that. Otherwise, the relative minimum is -2. You can tell me that it's at x equals 1, but this is the minimum value in that area, okay? And in this case, I only have that one relative minimum, but I can have more on my graph. So you got to look very carefully. Now, relative maximum would be this point. And you guys can see that. It's higher than the points immediately to the left and the right, so it's a high point. And so if I wanted the coordinates of that, you can see that that's -1, +2. Or if I didn't ask you for the coordinates, if I just said what's the relative maximum, you would say I have a relative max of 2, and that occurs at x equals -1. Okay, so we've done that before with polynomials. But now we want to talk about end behavior. End behavior means what is my graph doing at the leftmost side, and what is my graph doing at the rightmost side. So I'm going to talk about the right side, okay? And the way we're going to write this for now is we're going to say as x approaches infinity. And what that means is as I go as far as I can in this direction. So as I go as far as I can in that direction, what is the y value doing? So as x approaches infinity, y approaches what? Well, as x approaches infinity, you see that those points are going to get higher and higher because there's an arrow here and that's going to keep going up. So as x gets infinitely large, y in this case also gets infinitely large. So y approaches positive infinity because it's going up. So that's the notation we're going to use. If we're looking at the left side of our graph, we're going to say as x approaches negative infinity. Oops, not -8, negative infinity. This part and this part's going to be the same. This part for the right side, this part for the left side. So as x approaches negative infinity, what happens to the y values? Well, at this x, I'm going to be somewhere down here, and the further I go, the further down I'm going to be because this is going to keep on going. So as x approaches negative infinity, y also approaches negative infinity, okay? And those are all the key features of our graphs. So now we're going to just practice with a couple examples. I want you to take a minute and I want you to look at this graph and I want you to identify your x-intercepts and your y-intercepts. And then check your answer with me. Okay, remember x-intercepts are where it crosses the x-axis. So I have one here, 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 and here. I have 4 of them. And so you just need to find those points. So this is going to be -3, 0. Remember the y value will always be 0. I have one at -2, 0. I have one at -1, 0. And I have one at 0, 0. Okay, so you guys are familiar with that. That shouldn't be a problem. My y-intercepts are where does it cross my y-axis, and the only one in this case is 0, 0. So also at the origin. There's no other y-intercepts. Okay, now I want you to take a minute and write down what you think the domain and range of this is, and then check your answer with me. Okay, domain. Remember, we're looking for x values, and this has an arrow technically, and this has an arrow. It's going to keep on going. So this one's going to keep on going, and it's going to get bigger this way, or wider this way. It's going to get wider this way, so I'm going to have all these x values are okay. And this one's going to get wider this way, so all of those x values are okay. And so my domain is all real numbers. Okay? Now, for my range, I need to look at my y values. Well, you can see that these are both going to keep on going forever. So this way it's going to go on forever. But it doesn't go on forever this way. So this is my highest point in my y value. So my my range is actually when y is less than this point, because this is my high point. And you can see that the y value of both of those are 1. So this is the highest point, and then it'll go on forever in this direction, and so y is less than 1 is my range. Okay, so you got to look at those graphs carefully. Okay, want you to take a minute and look at your graph and find your relative maximums and your relative minimums. Okay, this is a relative max. So the coordinate for that is -2.618, 1. And again, we can say I have a relative max of -2.618 at x equals 1. So I'm showing you both of these on this video, but you're only going to write it as a coordinate if I specifically ask for the coordinates. Otherwise, you're going to write it like this, okay? This is also a relative max. So I have another relative max at -0.382, 1. So I would say relative max of 1 at x equals -0.382. And those are the only two relative maximums on this graph. So now my relative minimums would be any low points. And this one right here, even though it's not the lowest point on my graph, it's lower than the point immediately to the left and the right of it. So it's a low point. So I have a relative minimum at the coordinate, let's see, negative 1.5, comma, oh, I'm sorry, I gave you the coordinates here. So negative 1.5, negative 0.563. So I would say I have a relative minimum of relative minimum of the y value, negative 0.563 at x equals negative 1.5. And this is the way you will be writing it unless I specifically ask you for the coordinates. Okay, I think everybody should be pretty good with those. So now I want you to be really careful with this. And I want you to look at this graph and I want you to find the intervals where f of x is positive and then the intervals where it's negative. Okay, so take a minute and then check your answer with me. Okay, so remember positive means above the x-axis. Y values need to be positive, so it needs to be above the x-axis. Okay, so if I start tracing the graph, it's not above the x-axis, it's not above the x-axis until we get right past this point. So it's above the x-axis here. So between this point and this point. So it's above the x-axis when x is between negative 3 and negative 2. And then I'm below the x-axis, but over here, right after this point, I'm above the x-axis again in this area. So between those 2 points. So it's also above the x-axis from negative 1 to 0. So those are the two intervals where it's above the x-axis. So now, where is it below the x-axis? Because that's what negative is. Below the x-axis is when my y values are negative. So I'm below the x-axis here up to that point, and that point is negative 3. So to the left of this point, I'm below the x-axis. So when x is less than negative 3. Here we know already that I'm above the x-axis, but here you can see between this point and this point, I'm below the x-axis. So between those 2 points, between negative 2 and negative 1, I'm below the x-axis. And then I'm above the x-axis here. And then starting right after this point, I'm below the x-axis again. So again, when x is greater than 0, when x is this direction. So I had 3 intervals here where it's below the x-axis, okay? So you've got to be really careful with that and make sure you're thinking about the y values being positive or the y values being negative. Okay, so now take a minute and find where is the graph increasing and where is the graph decreasing, and then check your answer with me. Okay, so remember increasing again means going up. So if I start tracing, am I going up? I am. I'm going up and I'm going up and I'm going up until I get to this point, which has this x value. So that's to the left of that. So I'm going up when x is less than negative 2.618. Then I start going down and I'm going down until I get to here, which has an x value of negative 1.5. And after that, I'm going up again. I'm going up until I get to here. So from this point to this point, I was going up. So from negative 1.5 to negative 0.382, I'm going up. Okay? And then I'm going down, and I just continue to go down forever. So these are the intervals where I'm going up. If I want to look at the intervals where I'm decreasing, that means where am I going down? So again, when I'm tracing it, I'm going up until I get here. But between this point and this point, if I trace from left to right, between those 2 points, I'm going down. So between negative 2.618 and negative 1.5, I'm going down. Here, I'm going up until I get here. But then after this, to the right of this, I'm going down, and I'll just keep going down. So when x is greater than negative 0.382, because that means to the right. Okay? All right, last part of this graph, I want you to take a minute and I want you to find the end behavior. So the left side of the graph, remember we're going to say as x, this says left, so as x approaches negative infinity, what is y approaching? And then this says right side, so as x approaches positive infinity, what is y approaching? So I want you to take a minute and try that and then check your answer with me. Okay, so be careful because this one's the left side first and we're used to starting with the right side. So on the left side here, I'm going to say what's happening to the left side? The further I go this way, the further I go this way. So it's approaching negative infinity. My graph is approaching negative infinity on the left side, okay? On the right side, the further I go this way, happens to also be approaching negative infinity because that'll keep on going forever. So in this case, on both sides, it's approaching negative infinity. Okay, so they can be the same or they can be different. Okay, so what I want you to do is I want you to finish this, finish your notes, okay? So I want you to answer all of these questions on this part of your notes and all the way through it, because it's all based on this graph, and have those answers with you and available in class, okay? So I want you to try those, and then we'll look at them in class.